Okay, we're up. All right, you guys out there, you hear me? Terrific. All right. You guys like that Cloud9? Come on, type something in. We're all looking at you. Thanks. Is it really still snowing out, guys? Yeah. Is there any newer forecast of when it's going to stop? Is that right?
It's going to start. It's not going to be a blizzard, actually. Yeah. I think it'll take probably overnight.
All right. Well, we'll figure it out. Okay, so what we're going to do here is we're going to do the sorting. Let me actually, I'm going to pretty much do this from scratch, really. Let me open up my console. And so I'm going to create a new directory called sort. And let me open things up here. So we're going to have some test. I'm going to describe, we'll start out with bubble sort. Let's see. Here. So annoying. All right, so what we're going to do here is we're going to have this actually start out with our specs. And for our bubble sort spec, let me spell it right. So we're going to say describe bubble sort keep it simple. So one of the things you could do here, I don't know if you noticed this, but you could nest describe blocks. So you could say describe sorting 3, 1, 2. It returns 1, 2, 3. So we put an expectation here. Expect bubble sort 3, 1, 2 to equal 1, 2, 3. And I think with expect, I want to get my value, and I'm going to do my comparison here. So it should look like that. So once I do that and I run test them, and I open this up in a browser, Should see that test fail. Doesn't seem like it's running. You do have to put that. Maybe I'm not in the right folder. Hold on. I thought I was. I'm not. Okay, so just make sure that these guys are back. Okay. So we can see that our test fails. Let's go ahead. We'll implement bubble sort. Okay. And we can do that in our bubble sort. So what we're going to do here is we're going to have this function called bubble sort. We're going to pass in this array. And what we're going to do is we're going to start out by setting this flag sorted equals false. And we're going to keep on going through this and say, while we're not sorted, we're going to sort. And once we get in here, we'll say sorted equals true. And just to see that we're able to call this at least, that it loaded, let's just return an empty array. Or we'll just return what was passed in. So we go in here, we're not sorted, then we're sorted, so we only go in there once. And we see that we don't have something that's sorted. Okay. So what we're going to do here is that we're going to loop. And we're going to go from I equals 0. Let me make this a little bit bigger. From I equals 0, as long as I is less than the array that was passed in, the length minus 1. There's a number of different ways that you could do this. Do I plus plus. And we're just going to ask, once we get in here, if array I is greater than array I plus 1. If it is, we know that we're going to have to do some sorting. And what we're going to do here is that we're going to say, okay, let's do a temporary value. We're going to store array I in a temporary value. So we have the old value for array I. And we could now say array I. That's not right. Array. Yeah, that's right. Array I equals array I plus 1, right? And we could say array I plus 1 equals temp. So we store this value. We then overwrite this place in memory with the other value, and then we take the thing that we put in memory, right? And we have temp, so we've swapped out our values. And in this case, we could say sorted equals false. Every time that we end up going to this while loop, we assume that things are going to end up being sorted. If they're not, we say sorted equals false. And this passes. Okay? There's one thing we could do to modify this to make it a little bit more performant, that we actually don't have to go all the way to the end. We could actually go up, actually knock off I, right? Because again, just think about when we go all the way to the end, we know that the highest thing is going to be bubbled up all the way to the top. So, you know, if 8 was anywhere, let's say the highest value was 8 and 8 was in the middle, we're going all the way, 8's going to be on that end spot. So next time we go through, we don't have to go all the way to the end. We could optimize it a little bit here. That makes sense? And that should still pass. Anybody getting the infinite loops doing this? It doesn't pass.
No, I mean, I think you're making sorted equal to true. Shouldn't that exit your loop right away?
No, I think it was this thing that killed it.
Yeah, I don't think you can do that. So you're coming in on both ends.
I thought you could. Maybe you can't. All right. I know that there is some way to optimize this. I mean, I am thinking, do you have to go? You should be able to, if your biggest value winds up on the right, then the next time through.
You know, I think you need a variable in the outer loop, Eric,
Yeah.
and then increment it for each outer loop.
You put a variable in the outer loop.
Yeah, like a J.
Okay.
And it'd be the way like my sign on J. And then you increment it after each unit for which is complete.
All right. So tell me here. So we do.
I don't know.
All right. Well, you know, we'll figure it out. I know that there is some optimization, but
You need a nested loop. Yeah.
okay.
So I'm thinking, so var j equals 0, and then in the inner loop, what you did except j instead of I,
Mm-hmm.
minus 1 minus j, and then at the end of the for loop, you do a j plus plus.
Ah, okay. Right. You might be right. Let's see. J plus plus out here.
Correct.
Well, then every time it goes through the while loop, J is going to go back to 0.
Right, so sorry, so j has to be initialized outside of while.
Yeah.
Okay.
Oh, I think that feels like the same thing. Maybe it's not.
It's different, it's a different loop.
You're right. Okay. Right, every time you go through there. Yeah, I think you're right. Okay. It's not as it's incrementing through the loop. I don't want to change it as, okay. All right, cool. So let's now take a look at the merge sort. And let's add a merge sort.js. Let's add a merge sort.spec.js. And so for our spec, we're going to describe merge. Well, all right, we're going to describe a merge sort. But before we describe a merge sort, let's describe merging. So to describe merging, we'll say merges two arrays which have been pre-sorted. So we expect, by the way, one of the other things you could do here, I don't know if you've done this with using any of these testing frameworks, but we could do something like expect result to equal, and let's say we expect 1, 2, 3, 4, 5. We went to go run this now, right? We get this error, results not defined. What we can do is we can have a before each. Before each will run before each of the specs in the describe. And the way that you usually end up doing this is you set up your result out here. And if I was to say result equals 1, 2, 3, 4, 5, that would end up passing. But really what I want to do is I want to say result equals merge. And let's say that I'm going to have 1, 3, 4, and I'll have 2 and 5. Now, it'll tell me that merge is not defined. I'll go over here and merge sort. And this is going to end up taking 2 arrays. I'm going to call this left and right. So now it's defined, it's not returning anything. I could say return left. Doesn't work. I could say return left, concat right. That's not going to work. So again, I want to go in. The main takeaway here is I want to basically figure out, I want to go and look at the front of each of these arrays, and that's going to tell me the next one that I have to, pull off the stack. So what I'm going to do here is I will specify while left dot length and right dot length. Because it turns out that one of them is done, right? That means I could just take what's ever left on the other one because that's already in sorted order and attach it on to the end. So while this is true, what I'm going to do is I'll say if left 0 is greater than right 0, then I'm going to have, and again, this is where you saw with the bubble sort, there was no creation of a new array, right? We just ended up swapping in place. With a merge sort, we end up setting some results here. And we say results dot push. And so if left is greater than right, we'll say we're going to take right and we'll shift it. And otherwise, we're going to have left shift. Right? So if left is greater than right, it's probably easier to think about it this way. So left is left than right, shift left. Otherwise, do it on the right. And we can make sure that we return our results. And if we look at test them, we don't quite have all of our data. We don't have the 4 and 5 getting back, right? We've got on in here, and we've got one, 2, 3, 4, right? We have 1, 2, 3, 4, and then our left is basically done, but we still have something left on the right side. So what you can do here, pretty simple, is before you return, you could say if left dot length results. Again, you have to remember to assign it to a new variable. We could say results dot concat left. If it's right, dot length results equals results concat right. And that should take care of the merge function for us. Right? So we know how to merge things. Now we have to actually set up our merge sort. So for the merge sort, what we'll do here well, before we do that, let's actually write our test. So here's our merge sort spec, describe merging, and under here we'll describe merge sorting. Again, all these end up taking a callback, and we'll say, and we can do another describe if you want. Describe using 9, 10, 2, 7, 5. And we could say it will return 2, 5, 7, 9, 10. So we have an expectation, and again, we could use our results here too, to say result to equal now, again, the result is defined in this before block. Again, these take regular scopes like closure here, nothing really different. And here it's going to tell us that result is not defined. And we could go over here and we could say before each. And put our result out here so we could use it. And say result equals merge sort. And we're going to use this array. Okay. So now it should tell us that merge sort is not defined, and now we'll create it. So for merge sort, we're going to pass in an array. And we're going to end up returning something. And the way that we're going to go about doing this is we're going to think about our end case here. So we have an end case that says that if the array that we pass in, if array.length is less than or equal to 1, return it. Sorted already. Otherwise, we don't have to do otherwise because we have a return here. We'll say middle equals array.length divided by 2. And we'll say math.floor. So now we could say left equals middle, left equals array dot slice, starting from 0 up to the middle. and right equals array dot slice. The middle going. But once we end up getting these two arrays, what we can do is we could say left, I want to reassign you, and I'm going to reassign you by merge sorting you. And for right, I'm going to reassign you by merge sorting you. And when we're done, what we're going to do is we're going to return merge left and right. Now, again, let's just think about this out, right? We go in here with two elements. Go in here with two elements. Our array length is not less than 1. We end up splitting this. Math floor of 2 divided by 2 is 1. So we end up getting our first element. We end up getting our second element. We then tell this to merge sort. It goes in here. It ends up returning itself. The other one ends up returning itself. Then we call merge on it. Merge is going to compare these two one-element arrays and put them in order, and we'll have a sorted list. Now, again, if it works for the base case plus one case, why is it going to stop working? It should keep on working, right? So, again, if we have some faith in the recursion, then this should pass as well. That makes sense to folks? Yeah? It's kind of an interesting one, because for whatever reason, I think you expect it to be more complicated than it is. And again, it's a fairly simplistic solution. Let me see if these guys online have any. If you guys online have any questions, you could Slack them over to me or the group or whatever. The other thing is that you could also, run this to just determine, create a random list, determine, stuff to run. You could also go in and calculate the number of things that happen when it ends up doing a merge sort. So, I guess if you wanted to do that, something you could do is, just to see, you could pass in some kind of counter. And if you think about the number of times the sort of number of operations, I think you have to think about from the, how many times do you end up calling this? How many times do you end up splitting, right? That's really what's going to tell you what the number of operations are. And if you run this, it'd be sort of interesting. If you do that calculation, how close that ends up coming to n log n. Again, the bigger the number, the closer it should end up being. So those are two examples of sorting algorithms. There's some other sorting algorithms that are out there that you could take a look at. Again, there might be some variations on this, on this theme. And one thing to do, again, just to make sure that you have a good feel for this, is to, whether you do it here, whether you do it with JSBin, pop this thing open. See, at this point, you've seen the times. It should be pretty quick to go in and write and, come up with an answer. And I'll come up with, I think people sort of like the recursion part of it. So we'll try to come up with just some examples that we could go over in class that'll sort of keep this in front of us. Because the fact is, you don't really see this stuff on a regular basis. You will see it from time to time. And I guess, at least for me, the first time I see it and I write a solution, it's not at all uncommon for me to write an infinite loop and see things crash and then go in, forget that I forgot about my base case or that sort of thing. But there's a number of exercises that we'll end up doing when we end up getting it. So the second part of this program, we do something called a Reacto, which is So one person gets to interview, the other person gets to get interviewed, and you whiteboard out your answer. And very often those things end up involving some recursion. So there was one that we did where, depending on how many squares we had in a grid, how many different combinations could we go through, to get from one point to the bottom, or that sort of thing. And that was also one of those recursion things where if you figured it out for a grid of 4, it just became a question of adding up your previous results or to get your answer. So that's a good one. I'll take a look and I'll find that. At this point, let's stop. I'm going to stop sharing this. I don't know what we have left to do, although I'm terrified of leaving the building. So for you folks that are remote, we're going to plan on getting back here tomorrow. I don't know. I mean, hopefully things will be plowed up, so things should be somewhat normal, hopefully. And again, just sort of a heads up in terms of what we're going to end up looking at. We'll start out with looking at this Game of Life, which is, I think, a really nice workshop to do. We'll end up reviewing that. We'll end up going into looking at Node and seeing how Node is different than JavaScript, how Node has this system for keeping things modular by using these a module by doing an exporting system and requiring things. So we'll take a look at that. We'll look a little bit at asynchronicity, and that's going to take us. I think we're going to have a little bit more of that workshop to do on Tuesday as well. So that's a fairly lengthy workshop that we'll end up doing, and we'll end up. You'll have a review video up for that on Wednesday. Then we'll start getting into Express. We're going to build a site that uses static JavaScript data using Express to basically have users that have tweets. That's sort of common thing. And from there, we'll end up eventually, from there we'll end up moving over to how we could store that data. So we'll start looking at SQL. We'll end up doing some workshops with SQL, and let me just double check on this just to see where. Yeah, so somewhere along so and then we end up coming back and we end up doing Twitter with SQL, where we end up using an ORM called Sequelize. So a bunch of things that are coming up. You're going to get very comfortable with promises, with Mongo, get some familiarity with SQL. So a fair amount that's going to be coming down the pike in the next couple of weeks. Watch out for the abominable snowman when we leave here. All right, hey, guys, if I have something else to say online, I'll let you know. Let me post this link, and I'm also going to push up this repo as well.